PhDs weren't always hyperspecialized. Aristotle is a prime example of an ancient Greek polymath, making significant contributions to fields such as philosophy, biology, and physics. His works encompassed a wide range of subjects, from the study of animals to the movement of celestial bodies. This broad approach to learning was common among ancient Greek philosophers, who often studied various subjects without specializing in a single field, laying the groundwork for a more generalist approach to intellectual inquiry. The 19th century marked a significant shift in the academic landscape, as modern academic disciplines began to take shape. This period saw the establishment of distinct fields of study, each with its own methodologies, journals, and professional organizations. The development of physics as a separate field is a prime example of this trend. Prior to the 19th century, physics was not a distinct discipline, but rather a subset of natural philosophy. However, with the work of scientists such as Maxwell and Thomson, physics began to emerge as a unique field, with its own set of problems, theories, and experimental methods. As a result, PhD studies in physics became more specialized, with students focusing on specific areas such as thermodynamics, electromagnetism, or mechanics. This increased specialization was driven by the need for greater depth and precision in scientific research, as well as the growing complexity of the subject matter. The emergence of modern disciplines like physics led to a greater fragmentation of knowledge, and PhD students began to concentrate on narrower and more specific areas of study, laying the groundwork for the hyperspecialization we see in PhD programs today. The 20th century witnessed a significant surge in PhD specialization, driven by the emergence of new fields and subfields. One notable example is the rise of computer science as a distinct field. Prior to the 1960s, computer science was not a recognized academic discipline, and researchers in this area were often housed in mathematics, electrical engineering, or physics departments. However, with the establishment of the first computer science departments and the introduction of dedicated academic journals, the field began to take shape. Government funding, particularly in the United States, played a crucial role in this process, as agencies such as the National Science Foundation and the Department of Defense invested heavily in research and development. The proliferation of academic publishing also contributed to the trend, as researchers were increasingly incentivized to produce specialized knowledge and publish in niche journals. As a result, PhD studies in computer science and other fields became more narrowly focused, leading to a proliferation of specialized experts and a fragmentation of knowledge. This shift has had profound implications for interdisciplinary research and innovation, highlighting the need for a more nuanced understanding of the relationship between specialization and progress. In conclusion, the evolution of PhD specialization has been a gradual process, from the polymaths of ancient Greece to the modern-day hyperspecialists. We've seen how the establishment of modern academic disciplines in the 19th century and the explosion of new fields and subfields in the 20th century have contributed to this trend. The impact of government funding and academic publishing has also played a significant role in shaping the modern PhD landscape. As we move forward, it's essential to consider the implications of hyperspecialization for interdisciplinary research and innovation. The increasing complexity of modern problems requires a more integrated approach, and PhD studies should strive to balance depth of knowledge with breadth of understanding. Ultimately, the future of PhD research depends on finding a balance between specialization and interdisciplinary collaboration, and by recognizing the value of both, we can foster a new generation of scholars who can tackle the complex challenges of our time. And the key takeaway is that a balanced approach to PhD specialization is crucial for driving innovation and progress in various fields.